Regarding master alarm panels in hospitals and their power source, specifically in a scenario where one of the required master alarms is located in a separate building without a life safety panel, the question arises whether it's permissible to run a feed from a life safety panel located within the main hospital building. The answer is that there's no code specifically prohibiting this practice. To elaborate, NFPA 99 mandates that master alarm panels for medical gases be fed from the life safety branch of a hospital's emergency system. The life safety branch is designed to provide essential power during power outages, ensuring critical systems remain operational. The code allows for flexibility in how this power is delivered, particularly when dealing with remote buildings. The key considerations are maintaining the integrity and reliability of the life safety power supply and ensuring compliance with all applicable codes and standards. When extending a feed to a separate building, several factors must be taken into account. These include the voltage drop over the extended run. Excessive voltage drop can impair the operation of the alarm panel. Calculations should be performed to ensure the voltage of the alarm panel remains within the acceptable range specified by the manufacturer, even under worst-case load conditions. Proper conductor sizing is crucial to minimize voltage drop and prevent overheating. Another consideration is the overcurrent protection. The feeder must be adequately protected against overcurrents such as short circuits or ground faults. This typically involves installing appropriately sized circuit breakers or fuses at both the supply and load ends of the feeder. Selective coordination of overcurrent protective devices is important to ensure that only the closest device to the fault trips, minimizing disruption to other critical systems. Isolation and surge protection is also something to keep in mind. Consider using isolation transformers and surge protective devices to safeguard against electrical noise and transient voltages that could damage the alarm panel or interfere with its operation. This is especially important when running conductors between buildings, as they may be more susceptible to lightning strikes or other electrical disturbances. Grounding and bonding is required to maintain a low impedance ground path and prevent the buildup of static electricity. Proper grounding and bonding are essential for safety and to minimize the risk of electrical shock. Verify the grounding system meets the requirements of the applicable electrical codes, such as NFPA 70, the National Electrical Code. Communication and signaling is also important to note. If the alarm panel communicates with a central monitoring system, ensure the communication link is reliable and protected against power outages. This may involve using a separate uninterruptible power supply for the communication equipment. Compliance with other applicable codes and standards is a necessity. In addition to NFPA 99 and NFPA 70, other codes and standards may apply, depending on the specific installation. These may include local building codes, fire codes, and accessibility standards. Documentation is also something to keep in mind. Keep detailed documentation of the installation, including wiring diagrams, voltage drop calculations, overcurrent protection coordination studies, and grounding system details. This documentation will be valuable for future maintenance and troubleshooting. Finally, it is imperative that all work be performed by qualified personnel such as licensed electricians and fire alarm technicians. These individuals should be familiar with the applicable codes and standards and have the necessary training and experience to ensure a safe and reliable installation. In summary, while running a feed from a life safety panel in the main hospital building to a remote building for a medical gas master alarm panel is permissible, careful planning, execution, and adherence to relevant codes and standards are paramount.